You need to watch this if you struggle with keeping your systems reliable and scalable. Hi, I'm Pankaj Sharma, and in this series, I'll guide you through the world of site reliability engineering the Google way. Site reliability engineering, or SRE, is a discipline that takes the principles of software engineering and applies them to infrastructure and operations problems. Imagine you have a team that builds a product. You also have another team that keeps that product running smoothly for customers. SRE essentially says, let's use the same smart, systematic, data-driven approach we use for building the product to also run the product. It's about treating operations as a software problem. This means instead of manually fixing issues over and over, SREs write code to automate solutions, build systems to predict failures, and create frameworks that make services more resilient and dependable from the ground up. The core idea is to create scalable and highly reliable software systems. This isn't just about keeping the lights on, it's about engineering a system where the lights rarely flicker in the first place. SREs spend their time on tasks that have long-term value like automation, performance tuning, and capacity planning. They aim to eliminate toil, the manual, repetitive, tactical work that provides no enduring value and scales linearly with service growth. By focusing on engineering, they move away from a reactive firefighting model. This shift in mindset is crucial. It transforms the operations function from a cost center into a source of innovation and stability, directly contributing to the product's success and user satisfaction. A fundamental concept in SRE is the service level objective, or SLO. An SLO is a specific measurable target for a service's reliability. For example, an SLO might state that 99.9% of user login requests over a 30-day period should succeed in under 200 milliseconds. This isn't just a vague promise of high availability, it's a precise contract. This contract guides everything the team does. It helps them make data-driven decisions about when to push new features and when to focus on reliability work. If the service is meeting its SLO comfortably, the team has an error budget, a calculated amount of acceptable downtime or performance degradation, which they can spend on innovation and releasing new features. This error budget is the genius of the SRE model. It provides a common language and a shared set of priorities for both development and operations teams. When the error budget is spent, all new feature releases are frozen. The entire team's focus must then shift to improving reliability and stability until the service is back within its SLO. This creates a powerful, self-regulating system. It prevents the all-too-common conflict where developers want to ship features quickly while operations staff plead for more stability. With SRE, both sides are working from the same playbook, guided by the objective data of the SLO and the clear rules of the error budget. DevOps is a culture, a philosophy, and a set of practices that aim to break down the silos between development and operations teams. It's about increasing an organization's ability to deliver applications and services at high velocity. The goal is shared ownership, improved collaboration, and faster, more reliable software delivery. DevOps describes the what and the why. We need to work together to build and run software better. However, it can sometimes be, a little vague on the how. It provides the principles like automation and continuous integration, but doesn't always offer a prescriptive framework for achieving them in a large, complex organization. This is precisely where site reliability engineering comes in. If DevOps is the philosophy, SRE is a concrete, class-based implementation of that philosophy. SRE provides the specific roles, responsibilities, and practices that bring DevOps principles to life. It answers the how. For instance, the DevOps principle of shared ownership is implemented in SRE through the error budget. Both developers and SREs share responsibility for managing this budget. The DevOps goal of automation is a core tenet of SRE, where engineers are mandated to spend at least 50% of their time on engineering projects that automate away manual toil. Consider the DevOps goal of bridging the gap between dev and ops. SRE achieves this by creating a team of engineers who have a hybrid skill set. SREs are typically software engineers by training who have a deep understanding of and passion for system administration and infrastructure. They can write production quality code, but they apply that skill to building robust automated operational systems. They sit in the same meetings as developers, review code, and contribute to the architecture of the service from the very beginning. This ensures that operational concerns like scalability, monitoring, and disaster recovery are not afterthoughts but are baked into the product's DNA. This symbiotic relationship creates a powerful feedback loop. Developers working alongside SREs learn to write more operable and resilient code because they are exposed to the consequences of poor design choices firsthand. SREs in turn gain a deeper understanding of the product's architecture, allowing them to build more intelligent and effective automation. This collaboration fostered by the SRE model directly fulfills the central promise of DevOps: to deliver better products to users faster and more reliably. SRE doesn't replace DevOps. It provides a mature, opinionated, and proven way to make DevOps a reality within an engineering organization. Google is where the SRE discipline was born, and its approach remains the gold standard. It was founded on a simple premise articulated by Ben Traynor-Sloss. SRE is what happens when you ask a software engineer to design an operations team. At Google, SRE teams are composed primarily of people with software engineering backgrounds. They are not traditional system administrators who were taught to code. They are coders who are tasked with running a service. This fundamental choice in hiring and team composition shapes the entire culture. The default response to any operational problem is not to manually intervene, but to ask, how can we write software to prevent this from ever happening again? A key aspect of the Google model is the strict 50% cap on toil. Toil is the manual, repetitive, automatable work required to run a service. SREs at Google meticulously track their time to ensure that no more than half of it is spent on operational tasks like handling tickets, manual deployments, or on-call interventions. The other 50% must be dedicated to engineering projects, writing automation scripts, improving monitoring systems, conducting performance analysis, or contributing to the core product code to enhance its reliability. If a team's toil consistently exceeds 50%, management intervenes. The solution is not to hire more people to handle the toil, but to either give the team more engineering resources to automate it, or in some cases to hand the operational workload back to the development team. This handback mechanism is a powerful enforcer of quality. If a development team ships a service that is unstable or generates too much operational load, the SRE team has the authority to stop supporting it. The developers then become directly responsible for the operational burden, including being on call for any issues. This creates a very strong incentive for developers to build reliable, easy to operate systems from the start. It aligns everyone's goals toward a single purpose: creating a service that is stable and requires minimal human intervention to run. This is not a punishment, but a built-in quality control system that ensures shared responsibility. Furthermore, Google's SREs are deeply involved throughout the entire software lifecycle. They don't just receive a finished product to run, they participate in design reviews and production readiness reviews for new services. They have the authority to push back on launches if a service does not meet their strict criteria for operability, monitoring, and emergency response. This gatekeeper function ensures that reliability is a primary consideration long before a single line of code is deployed to production. This proactive, engineering-driven approach is the essence of the Google Blueprint, transforming operations from a reactive cleanup crew into proactive architects of reliability. The benefits of adopting an SRE model can be transformative for a company. The most immediate and obvious advantage is a significant improvement in service reliability and availability. By using data-driven SLOs and error budgets, organizations move from emotional debates about uptime to objective conversations about risk and innovation. This leads to fewer outages, faster recovery times, and ultimately happier users. For example, a streaming service implementing SRE can ensure that its video playback start time SLO is consistently met, reducing user frustration and churn. This reliability becomes a competitive advantage, building trust and brand loyalty in a crowded marketplace. Another major benefit is increased engineering velocity. This might seem counterintuitive as SRE places such a strong emphasis on stability. However, by automating away operational toil, SRE frees up brilliant engineers to work on value-adding projects. Instead of spending their days manually deploying code or restarting servers, they are building platforms for automated canary analysis, developing self-healing infrastructure, and improving system performance. Their budget also gives development teams a clear, safe framework within which to innovate. When the service is healthy, they can release features quickly, confident that they have a buffer to absorb any minor unforeseen issues. However, implementing SRE is not without its challenges. One of the biggest hurdles is cultural resistance. Shifting from a traditional operations model to SRE requires a fundamental change in mindset for both developers and operations staff. Operations teams may feel their roles are being automated away, while developers may resent the new reliability requirements and the idea of being on call. Overcoming this requires strong executive sponsorship, clear communication about the goals and benefits, and a commitment to retraining and reskilling staff. It is a journey that requires patience and a focus on building a culture of shared ownership. Finding the right talent is another significant challenge. True SREs, engineers with a strong software development background combined with a deep understanding of systems and networking, are a rare and highly sought after commodity. Many organizations struggle to hire for these roles and may need to invest heavily in internal training programs to cultivate this skill set. Furthermore, a lead implementation of SRE, where a traditional ops team is simply renamed SRE without changing their core function or giving them engineering time, is doomed to fail. A successful SRE adoption is a deep, long-term investment in people, tools, and culture, not just a change in job titles.